So for materials, we're going to use a 4-inch wide 2-foot PVC pipe, 2-inch wide 5-foot PVC pipe. All the PVC will be schedule 40. PVC female adapter, a PVC plug, a coupler, reducer, grill igniter, electrical tape, hairspray, sealant, and sealant primer. First step is we're going to apply a primer to both ends of the PVC pipe as well as the coupler. Following that, we will apply a sealant to both ends, as you see Alex and Matthias do here. Right there you see them putting together both pieces, creating an airtight seal. Next, we will apply the primer as well as the sealer to the other end of the PVC pipe as well as a reducer. Again, we will join these two pieces together, creating another airtight seal. Lastly, we will apply primer as well as sealant to the reducer as well as the barrel of our potato cannon. Again, they will put these two pieces together, creating an airtight seal. We decided that our barrel was just a little bit too long, so we cut a foot off of the end of it. Here, Courtney and I are deciding where we should put 2 holes for the grill igniter as well as the spark receiver. After we have decided where the 2 holes should be and both of the units fit, we will attach it to the combustion chamber permanently. Here we attach the ground wire as well as the hot wire to the grill igniter. We will then place the grill igniter on top of the combustion chamber and hold it down with black electrical tape, as well as we will tie the hot wire and the ground wire together and attach that to the side of the combustion chamber as well. Here will be an example of what the spark looks like from inside the combustion chamber.
Here, we start by taking a potato and cutting it in half. Then we take half of the cut potato and push it into the end using a broomstick so we can get it to the same point each time. We used hairspray as our fuel, and we held the cap close to the end to keep the hairspray from escaping, holding the can of hairspray as far in as we could. We measured the amount of fuel in seconds. On average, we used about 4 seconds of hairspray for each shot. We capped it tightly and then closed the end of the chamber. You shoot the cannon by pushing the red button on the spark igniter, and we each took a shot at it.
us know when.
Alright, ready? 1, 2, 3. Oh my jeez.
Whoa.
Alright. 3, 2, 1.
Oh, you can see the impact on that one.
Alright. Yeah, that's why it like
3, 2, 1.
For the energy balance of the potato cannon, we start with the basic energy balance equation. Our boundary condition is drawn around the entire cannon, with state 1 being before we fire with the gas and potato inside, and state 2 is after firing with only air inside. When we expand our equation, the energy in will be due to the air entering the chamber, and energy out will be due to the gas and potato being ejected. In our equation, the values of Z are equivalent and negligible as the cannon was fired from approximately sea level. We can rewrite delta E system, which is our change in energy of the system, as delta U system, which is equal to U2 minus U1, where U2 is equal to M sub A U sub A, and U1 is equal to M sub P U sub P plus M sub G U sub G. These values are substituted to the original equation, and then we solve the equation for the workout in order to have an equation to find the total workout of the cannon. This equation could potentially be simplified by finding the velocity of the air in and the gas velocity out in order to determine if they are negligible. The velocity of the potato can be found by using projectile motion physics.
For the entropy balance of the potato cannon, we start with the basic form of the equation. Entropy at state 1 minus entropy at state 2 plus entropy generated equals the change in entropy of the system, in this case, our potato cannon. For the entropy at state 1, we can expand it to the mass of the air in multiplied by the entropy of the air in, which consists of the mass and entropy of the air entering the system. For entropy at state 2, we can expand it to the mass of the potato out multiplied by the entropy of the potato out plus the mass of the gas out multiplied by the entropy of the gas out. Adding that, we have heat loss divided by the average temperature of the system. These terms account for the entropy and mass associated with the potato and gas leaving the system. In addition, we must account for the heat loss divided by the average temperature of the system generated by the combustion. Next, we can expand delta S system from the change in entropy equals entropy at state 2 minus entropy at state 1, where entropy at state 2 equals mass of the air times entropy of the air, and entropy at state 1 equals the mass of the potato times the entropy of the potato plus the mass of the gas plus the entropy of the gas. After all these substitutions, solving for entropy generated after rearrangement yields the final equation.
Our project is relevant to current technologies because it can be compared to things such as a combustion engine and modern-day bullets. In a combustion engine, you have a fixed cylinder and a moving piston. A spark ignites the fuel to cause combustion. These expanding combustion gases push the piston. We can metaphorically say that our potato cannon's gas chamber is the fixed cylinder and that our potato itself is the moving piston. But of course our cannon will only push this so-called potato piston out one time when it shoots. We can also compare our cannon to a modern-day bullets. A spark is created when the gun's hammer strikes the bullet. This spark ignites the gunpowder, which propels the bullet out. Similarly, our spark generator in the cannon ignites the hairspray, propelling our potato out of the cannon.